Hello! Welcome to the stream. David Snowpack here from Snowpack Games. I can see we've got a couple of people dropping in. We've got Art Fiend rocking some pointy armor and a beard. Boss MB Gaming, you have a pretty sweet character, Boss MB Gaming. You got some armor, similar armor to Art Fiend, but you also have like a braid and like a sun hat, and you're an orc. That's just a great combo. Time to relax and focus. Welcome to the stream. I got a pretty cool character too. I got an orc with possibly a mustache and a staff. Time to relax and focus got a pretty normal looking orc, but you know, he's got just a normal guy kind of shirt, but with a huge epic beard. We're looking good today. We're looking good. How are you guys doing? How have your game dev projects been going? Any interesting games you're playing? Whatever you guys got going on since last week? For my part, I don't have all that much going on. I'm really, really tired. I'm just exhausted from this week. Other than that, I mean, not that much has been going on. I guess I wrote down some things. I played D&D with my kids earlier in the week. I'd mentioned last stream that I was trying to get back into Dungeons & Dragons, and I managed to play like two 30-minute sessions with my kids and my wife, and the kids had about 30 minutes attention span both times, so it was like the shortest sessions of D&D ever, but it was fun. It was a lot of fun getting back in there. Video game wise, I've been playing Rogue Legacy 2. I don't know if anyone's been playing that one, but it's looking at D&D and looking at Rogue Legacy 2, I've come to realize that I just really like games with really strong class systems. Like I got the D&D player's handbook, and all I want to do is look at the classes because I just love classes. And Rogue Legacy 2 is a really strong class system. It's awesome. Otherwise, what are you guys saying? Boss MB says you can call me Micah. Yeah, cool. Very nice to meet you, Micah, by your real name. Hey, Logan. What character you get? You got a shield? Purely defense. You're purely on defense today. Logan, what is going on with your Twitter right now, man? I just saw you had like a crazy viral tweet with grass, which by the way was awesome, but like, man, that tweet got some legs. Hey, The Clean, welcome to the stream. Wow, the sun hat is getting popular. Micah and The Clean have it. Also some sweet orc braids. We got a lot of orcs today. Online game I played a lot when I was younger. Had an awesome class system, Ragnarok Online. I'm actually not familiar with that game. I'll have to take a peek at that. Yeah, that tweet went crazy. Oh, man. So, yeah, I'm glad to hear you guys are doing good. But, yeah. Today we are taking a break, probably a permanent break from working on the distraction timer, although maybe we'll go back to the distraction timer. I don't know. I still want to finish it. I still haven't managed to start really using it. There have been, there was like at least one, I guess I didn't go back to check, MR from someone who made an improvement, which was awesome. But otherwise, today we're going to be doing WebXR, which... If you're unfamiliar with WebXR, it's basically a technology to allow you to build AR and VR experiences that run in a web browser. So like the example people always give for AR is that you're on like a website selling furniture, and you see a piece of furniture you'd like, and you hit the like show it in my room button, and then it brings up an AR app, and you can look around your house and put the table or desk or whatever in your room and see what it looks like. Of course, that's something that has been possible from apps for like ever, but this would be, you know, just a web app, a web page that you loaded up, something in the web browser. And on the VR side, you can make fully immersive apps or games that again are delivered by a web page, which has the advantage of people just go to a web page to get it. They don't have to install it. And getting on various VR app stores can be tricky, particularly the Quest store. They are notorious for like just arbitrarily denying really good games from going in there. Sometimes games that did quite well, like on Steam and Steam VR, but they're just like, I don't know, we don't really want that one. So it's a potentially easier distribution mechanism. Hey, the buddy Adrian, welcome to the stream. Oh yeah, Micah was rocking the timer for school. I have trouble keeping like everybody's Discord, GitHub stream name straight. So Boss MB, you were the one who made the MR, right? Question mark. Yes, I will continue contributing. I have an idea for a pop-up issue. Sweet. Thank you so much for your contribution, Micah. That's awesome. What kind of character did a buddy Adrian get? Oh, just got a dude. You're just a dude. Just a dude, Adrian. All right. What was I saying? I was talking about WebXR. Okay, so I'm the maintainer of the WebXR module in the Godot engine. It works in Godot 3 insofar as it works. Like, it doesn't support everything in WebXR. I really should put more time into expanding what it can do, but we have it in Godot 3, and Godot 4 is coming out relatively soon. If the core engine team has their way, the beginning of 2023, which seems optimistic, but they're pretty committed. They are pretty committed to make it happen. So I want to get WebXR working in Godot 4, ideally before the 4.0 release. And there's a lot of stuff to do to make that happen. But the biggest, most complex, trickiest thing is this rendering thing, which we're going to work on today. We're going to work on the hardest, trickiest thing. So let's glove up. We're going to glove up for some drawing here. So there's a lot of challenges with rendering in VR. One of the big ones is that you have to render at a much higher frame rate. Like, the minimum frame rate for VR is 72 frames per second, but the other minimum is 90 frames per second. The 72 frames per second, I think that is considered like minimum because that's the frame rate of the original Oculus Quest. But before that and after that, like, generally 90 frames per second is when VR feels good to the, biggest kind of group of people, right? Because your tolerance for lower frame rate will have to do with like your tolerance for VR sickness. So 90 frames, right? So most desktop games are targeting 60 frames per second. You have to target at least 90. Of course, the Quest 2 can run at 120 frames per second. The Valve Index can run at 144 frames per second. So you can always go higher, but so a lot of frames. And then also, you have to render every frame twice because you have a left and right eye. And in Godot 3, it literally does exactly that when you're doing a VR game. It does the whole graphics pipeline for the left eye, and then it goes back to the beginning and does the whole graphics pipeline again for the right eye. So it's basically like if you're doing 90 frames per second, you're actually doing twice that as far as like frame rendering, like 180 frames per second. It's a lot. There is a technology, however, to improve this situation called multi-view, which is what Godot 4 uses for its VR rendering. And that basically works by doing both the left and right eye at the same time, but you're essentially doing twice as many vertices, twice as many pixels at every stage, right? So the projection is a little bit different on the two eyes. And this is going to be hugely exaggerated, right? Someone who's real cross-eyed here. So you have to process all the vertices twice for the two different projections, but you can do all of them at once, right? You're just doing double the vertices. You're doing, all of these in just one pass. You of course have to render double the pixels, but you can, just render more pixels on the same shader at the same time, right? So that's multi-view. And that is working in Godot 4 for the Vulkan renderer. WebXR, of course, uses WebGL. So we need to add multi-view support to the OpenGL renderer. And this is something that I've been working on like little by little over the past couple of weeks. And it's not terribly far along. But we're gonna see how far we can get it pushed along today. Any questions? I hope that wasn't too much explanation. I felt like last time, or maybe the last couple of times, I didn't give enough explanation. So that's why I want to kind of dive in today and make it super clear what we're going to be doing and why. Thank you, The Clean. So yeah, I'll show you what we've got so far. I mean, basically, because we don't have multi-view, if you try to use WebXR in Godot 4 right now, it'll just render the left eye. and leave nothing on the right eye, which hurts. It doesn't feel good. But we are not quite getting all the way to WebXR right now. We're just trying to get it working in the desktop first with OpenGL. And hey, Spimort, welcome to the stream. Lots of orcs today. Orcs with braids. So I'll show you. I'll show you what we got. Where's Godot? Don't I have Godot open in here somewhere? I don't. What is going on? Oh, probably because we're recompiling Godot. So I like compiled it and then tested it and then stopped it. So here, let's launch Godot from my custom branch here. Oh, and I always forget when we do C++ streams. There's a lot of waiting. We'll just have to chat more. We'll have to chat more in these in between times. I remember when we were doing a lot of stuff on SG Physics 2D on the physics engine, I would like have a little list of random things we could talk about while we were waiting for compiles, just to make it less awkward. Is it awkward for you? It's a little awkward for me. So let's get in here. This is a test project that I'm gonna show, which uses the mobile VR interface, which is this interface that I don't know if anyone actually uses for real. But you know how Godot has multiple like VR interfaces, which is essentially like backends. This is going to be less of a thing going forward because WebXR is going to cover a lot of pretty much most devices. But you'd have like an interface for Steam VR, an interface for WebXR, and you'd have an interface for the Oculus API. Then you'd have an interface for the Oculus Mobile API, and you'd load one up. So the mobile VR interface to me is just a test, but it's basically like what you could potentially use to power like a Google Cardboard. But rather than using the Cardboard API, you're just like rendering directly to the display. So anyway, we have this cube. I'm going to click. It is going to enter the mobile VR interface, and now we are seeing the cube on the left and the cube on the right. So I have gotten so far with implementing multi-view that it will make a separate variant of each of the scene shaders, like shader passes, for multi-view, and it correctly loads multi-view. But what it is doing is it is just rendering the left and right exactly the same. So we have enabled multi-view. We have got it rendering now to a 2D texture array rather than a single texture, so a two-layered texture. And then when we're drawing it to the screen for mobile VR, it's just copying layer 0 on the left, layer 1 on the right, but there is no difference in the projection. These are exactly the same. So what we need to do today, if it goes well, is we need to send two separate projections to the shader, one for the left eye, one for the right eye, and we also need to send different offsets because your eyes are also slightly apart, right? And the VR interface will actually tell Godot what the projection should be for the right and left eye and how far apart the eyes are. It does that not exactly that way. It gives like a full global transform for each eye. Or maybe it's not global. Maybe it's relative to the XR origin. I'm not entirely sure. But Godot will figure out for us what the distance is. And so we need to pass that information to the shader. Then we need to modify the shader to use it to do the two things different. Right? Make sense? Let's go. So before the stream, I was spending a bunch of time just like looking through the code, trying to figure out where things happen. The Godot renderer is a little weavy windy, like just trying to follow how data flows through it is a little tricky because of all the indirection, which is not surprising. When you have a renderer that can work, on Vulkan, on OpenGL, on DirectX 12, soon to be Metal, eventually to be WebGPU, right? There's a lot of indirection going on, but I think I found where we need to be. So let's go look at the shader first, because this is where we want to land in the end. So this is the scene shader for the OpenGL driver for Godot 4, and we get passed in the scene data uniform with all this data on it, which includes projection matrix, inverse versions of those, view matrix, and we need to pass in some extra data. If we go look at the equivalent of this in Vulkan, so I'm going to kind of be looking at what Bastian did for adding multi-view to the Vulkan driver, because I figure if I do it similar to the way Bastian did, probably like he and Bastian and Clayjohn are going to like it, as opposed to me just making up my own way to do it. But if we look at the equivalent shader in Vulkan land, it passes in these extra matrices. So we have projection matrix for each of the views. Max views, I'm assuming, is 2. I actually haven't checked what max views is set at. Wherever it's set, it's not set here. I guess we could search. I'm assuming max views is 2. It's not something you can really set arbitrarily, actually, because like the size that this scene data has to be is like pretty. It has to be a very specific size. So yeah, max views is set to 2. Do we have a max views variable in OpenGL land? It actually doesn't look like it. So maybe we'll define this max views somewhere, or maybe not. Maybe we'll just make it be 2. Anyway, we need to get this same kind of data added to the OpenGL shader, and then we need to change the shader to do some stuff. So I know a bunch of you folks are much better at rendering in shaders than me, so I'm counting on you. I'm counting on your help. Sweet. Thanks for letting me know, Micah, that it is making sense still. I'm glad. I have a feeling sometimes I wander off into the weeds and don't make sense anymore. Okay. Let's go back to here. Actually, no, let's go back here. Let's just copy this from the Vulkan shader, and we'll put it in the same spot here. We'll make some little changes. I don't know that it makes sense to have max views. I guess it doesn't hurt anything. Where does this max global shader uniforms come from? From outside of here. So we can look in the shader, see if it defines it here. That max, what was it? Max something. Yeah, I don't know where that's coming from. Okay, we'll sort of cheat, and we will just put in a 2. I mean, I suppose we could just define it at the top. Yeah, here, it'll go right here. Define max views 2. And we'll need to put it in the fragment shader as well. The way that Godot keeps these shaders in the OpenGL renderer is that it has the vertex and the fragment shader in the same file, which is really nice, and then just separates them by these little tag things here. Okay, so we put that in both the vertex and the fragment shader. I don't know that we'll actually need it in the fragment shader, but why not? Let's have it. All right. Now this data is in a UBO, uniform buffer object. Apparently the second one. Clayjohn has written a nice friendly comment for us, which I think I've tracked down in my bookmarking here. I think that is not render data. Okay, well it's nearby this. I think it's in the header for rasterizer scene GLES3. Yeah, here we go. So the scene date structure, state structure has this UBO structure, which is eventually what gets passed into that scene data. So we need to stick the same stuff here on the C++ end, and I am not entirely sure what that should look like. I mean, it's going to be, here, we'll just paste, nope, that didn't work. Nope. We will just paste this so that I have the right names, and then we will convert it to look C++y. So get rid of those precision things. Matrix over here is just a float array with 16 elements. Float 16. And then they really need to be vec4s. Well, so what would that be? How are we passing vectors here? I guess this ambient light color energy. That would be a vector. So maybe these are just floats with 4 elements. Oh, and you got to get rid of this max views, unless we want to define a max views somewhere in here. I don't know that the Vulkan side is doing that. So I also think I tracked down the Vulkan version of this. Possibly here? Yeah, here we go. And no, this isn't the same thing. This is a similar but different thing. This is scene rendered data stored very C++y. I don't know where or how this gets copied into the Vulkan version of a UBO, but bunch of things RD here. Here we go. This is where it gets copied into the Vulkan version of a UBO. And here is the UBO in question. Let's go check that out. And here we go. This is what this looks like in Vulkan. Maybe let's copy it. We did essentially the exact same thing, though. The code we just wrote is basically the same. So let's just bring it. Oh man, where were we? We were in rasterizer scene, possibly the header file of this. No. Okay, back to my bookmarks. Back to my bookmarks. We were here. Okay. Oh, jeez. Too many copy and paste buffers. Hey, Crabsoft, how's it going? The good news is we are working on WebXR in Godot 4. We're doing some engine hacking, working on Godot itself. Okay, so actually, I just want to compare this really quick. We did literally the exact same thing. We just didn't use this this constant. So when we do the same thing as what it turns out that Bastian did over in the Vulkan renderer, it probably means that we're doing it right. And apparently we have this constant already loaded. I think actually because this class is a child class of this class. We are right now in rasterizer scene GLES3, which, yep, is a child class of renderer scene renderer. Oh, this weavy, windy world inside the renderer. So many renderers, rasterizers, different things. Okay, so we now added it to the data structure for this UBO. We have a potentially interesting problem where the UBO has to be a multiple of 16 bytes, but I think that that is true by virtue of the data we just added. So a float is 4 bytes. So 4 groups of 6 or 2 groups of 16 would keep us at a multiple of 16. Keep us a multiple of 16. Yeah, and 4 by 4 is another multiple of 16. So this should compile. There's a static assert down here that makes sure it has to be a multiple of 16 bytes. Oh, Krebsoft missed the completion of the distraction timer. I like Supabase quite a lot. I may use it on pretty much any project where I want to have a database in the cloud somewhere, but I don't feel like building, you know, the API end of it, just using Supabase. Spitmort, are these changes you're going to propose to contribute to the engine? Or you keep... No, I'm contributing this to the engine. I'm the maintainer of the WebXR module in the Godot engine, and this is code that I need to get it working correctly in Godot 4. So this is absolutely going to be contributed. Actually, the PR already exists. It's just in a draft state. And once I get it working well enough, I'm going to undraft it and then ask Clayjohn and Bastian Oli to tell me what I did terribly wrong. And probably starting with like the architecture of it, and we'll probably hash out the details for weeks or months or whatever. So that's the reason why I'm doing this one first. Things that just touch the WebXR module, I can pretty much just like take care of. Things that touch the renderer are going to need a lot of input from a lot of people. Anyway, So we have it on the UBO data structure. Now we need to get it from, I tracked this down earlier. This data gets stored on the camera data object inside the renderer, inside the renderer scene renderer, possibly. And we need to copy it from there into here. So here is where it gets set on the camera data. So now it's in the camera data. Let's go through my bookmarks here. Okay, then this is the implementation of that camera data set multi-view camera. Cool. Now we need to find the place to take it from here and put it into that UBO, which not that long ago, we were here. Okay, so this is where the normal camera projection matrix is copied into the UBO. So what we need is set up environment to have access to this data, which I'm not sure that it has. And then we need to add a little loop to do loop over words. Loop over multi-view stuff and add to UBO. Okay. But we need to go one step higher, because I think this is passing us data within this render data GLES3 class, and I don't know that it actually has the data on it that we need, because we know it's on the camera data class. We need to make sure it gets over to this render data class. So let's go up here. Render data. Ooh, okay, cool. So render data GLES3 already has this. Brilliant. Okay, is that getting set anywhere? That is the next question. So we need to go to where setup environment is called. Go to references. Here, what we'll do is we'll just search for the text. Here we go. It's called right here. Hey Elliot, welcome to the stream. It is exactly like C++. We're doing C++. The last like 4 streams we were making a mobile app to like try and help me not get distracted, which I think that there may be something you might also be interested in, as I know we both have troubles with distraction. But we're going deep on C++ today. We are trying to get WebXR working in Godot 4, and we are handling the hardest, most difficult part of that, which is some changes to the renderer, Godot's OpenGL renderer. So, so we need to try and get this render data. We need to make sure that this render data class struct, whatever it is, actually contains the information we need from the XR interface. Okay. Ooh, all right. So I'm happy this code is here. It appears as though the data is being copied from the camera data to the renderer data, which will then get passed into setup environment. Beautiful. And the missing piece, the last missing link here, unless I just don't see it doing the thing that we need it to do. Yeah, it totally doesn't appear to be there. Is we need to copy this data and store it in the UBO. Let's go look at how that happened in Vulkan. We procrastinate by watching your stream. We're good. Thank you, or not. I don't want to distract more people. So we want to do exactly this same code that is happening in the Vulkan end, but over in the OpenGL end. So let's paste that and see what we have to change to make it work. So we don't have this correction. I think, oh no, we do have a correction. So there's a depth correction. View count, view projection, all this stuff is coming off of render. Ah, what did I hit? I hit something crazy. P render data, view count, that's there, right? Yep. And P render data view projection. And things are named a little bit differently here. We have scene state, UBO. And then this is not renderer RD, this is GLES3. And this is scene state. This is actually turning out to be quite a bit easier than I thought. Like, I'm surprised at how much code we could just copy from the Vulkan renderer. And the more we can copy from the Vulkan renderer, I think the more likely it is to be favorably reviewed by Bastian and Clayjohn. Hey, Mohammed, welcome to the stream. Let's, what do we gotta do here? We gotta change all these UBOs to scene state. Sorry, scene state, not scene data. And this comes from p render data. And I have a feeling that this fourth programmer third element on that vector 4 is just there to make sure that the UBO is a multiple of 16 bytes and it maintains that alignment that is required. Oops. P render data. I didn't look at what kind of characters you guys got. Oh, I missed Elliot's character. He's already gone. Muhammad got a pretty cool character, though. Got some armor, a shield. Looking good. Okay. Do we need to do this if the view count is 1? I mean, I guess it makes sense to initialize the memory to something rather than initializing it to nothing. Because I think it's passed in no matter how many views there are. What do you? Oh, there's Elliot. He's got a pretty normal looking person with a braid, a sweet braid though, or 2 Elliots. How many are you, Elliot? Oh, here you're like a professional wrestler. You're shirtless with the white pants and like a scruffy beard. Hey, Hex Toast, welcome to the stream. You got a pretty normal looking dude there with some long hair. Oh yeah. So people, I think particularly Crabsoft. You can thank Crabsoft. We're complaining about at the end of the stream there were just too many characters everywhere. So we did the end of a stream a couple of streams ago, making it fade away. But last stream it seemed like I felt lonely, like not having characters around me. So I increased the fade out time. It now takes 5 minutes to fade out rather than 30 seconds, which I think is a decent compromise. If someone's saying something every approximately 5 minutes, I don't feel like I'm alone over here. Okay, we may actually have done everything we need to do to get the data where we need it to be, and it's going to be really hard to verify that from inside the shader. So what I think we're going to do is we're going to run this app and put a breakpoint at the end of the pipeline of just passing this data along and make sure that the data looks like vaguely correct. And eyeballing some projection matrices is not like easy, but I think we can look at them and see if they're just a little bit off each other. And if we can look at the main projection matrix and see that it's a little bit off each other. And these eye offsets too should be amounts that are approximately the distance between, or the distance from the center of your head to an eye in metric, in meters. So that's what we're going to do. Thanks. Yeah, I like the longer timeout too. I do like the idea of Elliot going on every single service and creating a new character, but that sounds like a lot of work for Elliot as well. So I don't know if you're aware of this, Elliot. I think I told you once that I'm streaming to like a bajillion places at once, including Facebook and Twitch and some other spots. Okay, what am I doing? I am looking for the end of this pipeline, which is somewhere around here. I guess this probably is the end of the pipeline where we're actually setting data on the UBO. So let's put a breakpoint here. And let's run this. We will have to mute the breakpoints first. What is this other breakpoint? We don't need this breakpoint. Let's get rid of this other one. And we'll mute them so that it doesn't just like come the first frame that is rendered. And we will load up our app. We will switch it to VR mode, and then we will unmute that breakpoint and see what happens. See what we get. Yeah, if we actually have the data passed from the XR interface all the way through to the shader at this point, we are really, really kicking ass on this stream, first of all. But then we're down to just working on the shader, which I think is something that is maybe a little more approachable than me just like plumbing around in the guts of Godot's renderer. And also, it's something that you guys are going to help me with, because I am not terribly good at shaders. So we will see. And now we wait for the compiling. What should we do during the compiling? Draw some pictures. Oh, does anyone watch Edge Runners? The Netflix anime based on Cyberpunk 2077. I actually don't know if it's more based on the video game or if it's more based on the tabletop game that the video game is based on. But I watched the first 2 episodes last night with my wife, and they were pretty good. It was a lot different than I was expecting, but it's pretty good. Definitely very, very adult. It's a very adult anime, since animes range from kid-friendly to really disturbing, but it's pretty good. And it made me want to play the game again. Ooh, Elliot's rocking Facebook. You got the same character again, though? I wonder if it's just based on the name. If you're Elliot Christensen on Facebook and on something else, you might still just get that same character. Anyway, what is happening right now? Ooh, we broke some stuff. We broke things. Things are exploding. What have we done here? All right, so we are not going to kick ass on the stream as much as I thought we were, because we have to figure out what's going on with that. So what it seems like we made the UBO bigger, and now like the data isn't where it expects it to be. I should have kept that terminal up, and I should have done the thing I said we were going to do originally. Let's just run this again. We're still gonna stop at that breakpoint. Hey, Daniel Kaloka, welcome to the stream. What kind of character did you get? You got a peasant. You're rocking a peasant. Someone, a villager. Oop, terminal opened off on the wrong screen. Give it a moment. Should appear. Godot should appear over here. Let me move the terminal over if I can do it fast enough. Okay. Yeah, so what we're going to do is we're going to keep this terminal around so we'll have the errors to track down. And we are going to do the original test that I had in mind, which was to unmute these breakpoints and take a look at the data in here. So let's look. We have the scene state. Why don't I see that here? Scene state. Maybe it's on this. Where's this? Here's this. Scene state. We need the UBO. Where's the UBO? Scene state and the UBO. Okay. So we have a projection matrix. We have a projection matrix view. And we are going to attempt to eyeball that this data looks right. This data looks wrong. This data immediately looks wrong. We have the original projection matrix. I wish I could see. Can I make this? Okay. We have the original projection matrix up here. That's like if the camera was just a unitary camera instead of stereo. And then we have the left eye down here. They are identical, which I don't think they should be. I think they should be slightly different. And the right eye projection matrix is all zeros, so that's wrong. Let's go look at the eye offset. The eye offset is also all zeros. Okay. So something is preventing the data from getting here. So let's see what we can do with the call stack. See if we can step up the call stack and figure out what's going on. So we're up here now. Let's look at the render data. The render data has a view count of 1, which is wrong. So the render data must be getting its view count from the wrong place. Where is that set? That is set up here. So render data view count. This is where the magic should be happening, but it's not. Let's go look at here. This is where the camera data should be set to the right values. Let's, I don't know if this happens only once or every frame, but let's unpause, see if we can land here. The debugger can take us there. It is not. All right, it just keeps taking us back here to this spot. I'm just going to take one last look at the data on this UBO, and I'm going to see what everyone's writing in the chat, because you guys are writing a lot of stuff, but I haven't had a chance to take a look at it. This scene state, UBO, projection view matrix. Let's look at both of these. Yeah, still writing the wrong things. Okay. We need to figure out how to get here. PXR interface is null. It shouldn't be null. But let's, oh, I wonder if it's not being passed in? Okay, that could be the thing. All right, so let's just hit continue and see if we can land here. We landed here. Okay, we're getting closer. We're getting closer, folks. This function is supposed to be called with the loaded XR interface, and it is probably not being called. Nope, nope, it's not. It's just going down this way, even though it should be there. Let me go see what everyone's saying. Oh, geez. Get rid of you, 69 Omega. Let me find where I can ban you. Okay. Block and block. There we go. All right. So where to leave off? The internet was created for me to have 4 different chats open, 3 different live streams. It was. kind of an adult Stranger Things in German. Ooh, Logan's got an interview for Godot job. Congrats, man. I hope that goes well for you. Yeah, that's awesome, man. I'm glad you're making progress on getting yourself into some professional Godoting. That's awesome. All right. Whew. Let's see. So we need to track down where this function is being called, and we need to get the right data in here. So there is a thing in VS Code where I can like have it tell me like where it's called, but it never seems to work. Ooh, okay, maybe it worked this time. Render viewport. I've spent a lot of time in render viewport lately. That does seem like where it's being called. So let's go here, render viewport. And XR interface. Okay, that should be set right. Render viewport definitely touches the XR interface a lot of times. If the viewport has use XR set, which it should, or maybe it doesn't. Hang on a second. Did I fail to click? I have to click inside the window to turn on XR mode. Click. All right, well, something happened. Now let's redo our breakpoints. And now let's take a look at, okay, that's awesome. So I don't know if you guys are seeing what I'm seeing, but now the projection matrix views are filled with different data. The right eye isn't filled with all zeros. Let's go look at the eye offset. So would you say that your left eye is approximately 0.0299999993 meters off from the center of your face? Does that sound reasonable? That would be almost 3 centimeters? That the center of your left eye is approximately 3 centimeters over from the center of your face, and the same for your right eye? That sounds reasonable. You know, this is a fake device. It's not really measuring. I think the Pico Neo? No, not the Pico Neo. Is it the PSVR 2 has a feature where it'll actually like measure the distance between your eyes for you rather than having to go to a settings screen and like configure it. Okay, so let's take a look at the projection matrices. So here is the center of the camera, and they are different. The view ones are different than the central camera. And are they different from each other? They look identical to each other. Oh, no, not quite. Not quite. So this 8th element on the projection matrix, which I don't feel like counting to see which part of the projection matrix that is negative over here and is positive over here, which kind of makes sense. Again, I would have to count through there to see exactly which part of the matrix that is. Yeah, so they're slightly different in that little way. I think the right data is being passed in, so that's good. Okay, so instead of having 2 problems, we actually only have 1 problem. And the 1 problem is this. Somewhere, the size of this uniform is being set, and it is wrong. So I don't know where these messages start and where they end, but let's just copy one chunk of it. And we will make a little scratch buffer in VS Code. Scratchpad, new scratchpad. We'll call this errors.txt, or just errors. Come on. What's going on, VS Code? Oh, I have to pick plain text. Now errors. There we go, errors.txt. So let's go track down where these errors are happening and see if we can figure out how we can fix it. So shader GLES 3, this is the code that takes Godot shader language and converts it into GLSL. I've spent a little bit of time in there as well. We'll kind of make our view a little bit easier to work with here. And we're going to go to shader GLES 3 header, the header. And we are looking at 212. Okay, so this is saying something has gone wrong with compiling the specialization. This is probably, calling the underlying like OpenGL stuff to compile the shader. And then we have this which out of bounds. Let's see what that is about. Oh my god. 225, capital G. Thank you. And now we're down here, get version, get uniform. Okay, so this spec has the size of the uniform. Where does this spec come from? Well, that's a specialization, which I think is a big array at the top. Let's go to shader, or no, scene. So the Godot build system, SCONs, will take the scene GLSL and compile it into, or generate, I guess not compile it, generate this scene GLSL.gen.h, which has this stuff. Okay, so what exactly was it complaining about? saying spec uniform location size, that the index that was being passed into here was bigger than uniform location size. Form location. Oh, okay. Well, how does this uniform location get set? I am massively confused right now. Let's go back to this header. So what the heck is happening here? Version get uniform, which I think gets called by one of these. Yeah, version get uniform. It's being called for a particular specialization. The specializations are not things we're messing with. I had to add all these other variants, this color multi-view, additive multi-view, depth multi-view for the different like rendering passes. Elliot blames C++. I don't know, man. I blame me not knowing what the heck's going on in the renderer, but you know, blaming C++ is an easy target. No one will challenge you on it. So GL uniform 1i. Particular shader variant, particular specialization. So what it seems like, okay, spec is a version specialization from version variants p variant, looking up the pointer to the actual specialization. And what is a specialization? Specialization is this structure which, okay, has information about the uniform locations. And apparently we don't have enough uniform locations. There's a list of locations inside this uniform, and we don't have enough of them. So how does uniform location get set? What is setting uniform location? That is the big question. Uniform location. Oop. Oh, I thought Logan got stuck at the bottom of the screen. What Microsoft supposing to do? Rust human means everything MS thanks to fashion. That was me not getting totally distracted. Okay, so how does uniform location get set? What is setting uniform location? Let's go to the old search. We're going to search in Godot for drivers. What is it called? GLES3, I think the folder is called. Yep. We're going to search for uniform location. What sets uniform location? We want the lowercase one. Okay. So here we go. Spec uniform location resize to the uniform count. So this uniform count is coming from here, which gets called setup. What calls setup? References. Work first VS Code. Do it. Do it. It gets called by that generated code. So if we go to scene here, okay. So this what's the vertex code? The fragment code gives it a name. One of these arguments is the size. I actually showed it for a second. P uniform count comes right after the name. So it is a count of 9, but we're trying to access more things than 9. Let's go look at that struct that we changed and see if it has 9 elements without what we have. And then we got to figure out how this 9 can change to whatever we need it to be. So let's go to I think it was in material storage. The scene state UBO. Okay, so this scene state UBO had 1, 2, 3, 4, skip ours, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, so it wasn't a thing that was 9 that suddenly changed to something bigger. Out of bounds. Oh, interesting. Actually, the size of this uniform's location is 0. It's 0. I wonder if our shader needs to recompile, but it needs to this header needs to regenerate, but it didn't, or something like that. Let's try and force it to rebuild that. Was it scene GL SL gen H? Let's attempt to get it to rebuild that. We'll remove it. And we're going to pay more attention than I usually do to the compilation messages. Oop, we gotta, of course, quit here first. And let's mute our breakpoints. Actually, we don't even really need to run it. We'll just build it. On build task, build Godot 4, do it. Okay, so it built this GLSL header, and the size should not be 0 anyway, because we were it was clearly passing a 9 in there, right? All right, so it built. Let's go take a look in that header just to see if anything changed. Although I'm actually really confused now that I'm thinking about this more, because we definitely saw it passing a 9. Still passing a 9. Uniform strings. Why does this have a 7? So uniform count, uniform names. Okay, hang on. Name, uniform count, then uniform strings. So this uniform string should have the same number of elements. It has 9 elements. And that is what's setting this, right? We get into here. The P uniform count, follow that down here. It sets the uniform count, which then gets used to resize this uniform location. And so it should be 9. It shouldn't be 0. So how is it 0 over here? Also, this spec OK is true. Like, is that a result of something, or is that the cause of something? Let's move this back in here, give us a little more room to work with. And let's take a look at here. I wonder if, like, the shader is failing to compile. That was what line? 212 in the header. Should never happen. Okay, spec OK. Where does that get set? Or where does OK get set? Apparently not anywhere in this header file. Let's go look in the CPP file. Okay, equals true happens at the bottom of this giant compile specialization. So it sounds like maybe the shader is failing to compile, which should give us an error message, which we might just be missing because it's way off the top of the terminal. So I propose we turn on our breakpoints, we run it, and then it should stop when rendering the first frame, and then we can see what it says. Elliot says, I need to buy you a snazzy Snowpet Games banner for your streaming room. That would be awesome. I did recently get the new logo made. I don't know if you saw that, but it's got this like cute little face guy. So like that would look cool. That would look cool on a big banner. Yeah, because my walls are very, very blank, other than like the shapes that I've drawn on the pieces of paper that are on the wall. Okay, so this should not be repeating over and over again, right? Or is this the wrong terminal? Okay, here we go. This is the shader error. Struct type mismatch between shaders for uniform named scene data. Maybe we need to update the structure in both the vertex and fragment shader. How much you want to bet that's the issue? Let's go back to the scene GLSL, to the shader we were working on. One of the really nice things about working on this particular feature at this stage of Godot's development is that the OpenGL OpenGL renderer is still really, really simple, and there's not much in it. Like when ClayJohn eventually finishes it and puts all the stuff from Godot 3 back into it, like it's going to be really complicated. So if I could just sneak this in, just sneak in multi-view before he does that, it'll be way easier for me. Okay, so we have this uniform declared in both shaders because obviously we do. I don't know why I didn't think of that before. Let's try this again. So I'm going to mute our breakpoints, recompile, and let's give this a shot. Go. Yeah, the new logo with the little face character guy, I really want to make a game starring him, because I think that'd be really cool. I think it'd be really, really cool to have a, like right in the middle of the front page of snowpetgames.com to have a little game there, which I've in my mind titled Snowpet Games the Game, which could star the little logo character. I think that'd be so cool. So like you'd come to the webpage and you'd see the logo, and then that would be, you know, whatever the splash screen is for the game with like a button to like play, and then it would go. Yeah, it would be so cool. I would love to have something like that. The problem is I can't think of a good. I don't know what the mechanics for the game should be. Do you guys have any ideas? Like that character kind of makes me want to do like a top-down like ARPG style thing, but like I don't know if that's quite right. I thought about making some sort of like simulation kind of thing where like maybe the character could run around and do Snowpet Gamesy type things. I don't know what that means exactly, but like, you know, hacking on stuff, and I don't know. Sort of like the looking for coffee shops. Yeah. Snake, but all the sections are little dude faces. I mean, that would be cool too. The thing is that face just wants to squish and stretch every time I look at it. I just want it to, you know, get elastic. So I want to see it like bouncing, you know? I don't know what exactly. Oh, like hacking, like as in like, yeah. I was saying hacking in the sense of like working on open source software, but like hacking, the other kind of hacking would be really cool. All right, let's click it. Did we do it? Did we do it, guys? I think we might have done it. I think we might have done it. Like, I can't visually tell what's going on. Oh, no, because we haven't used it in the shader yet. Okay. Wow. Sweet. This is worthy of a little commit. Let's commit what we've got. So what did we do? We did this, which is not very much. Okay, let's commit it though. So we're gonna say got the eye projections and offsets to the scene shader. Okay. Krabsoff says the game is called Snow Peak, and you slingshot a soft body squish man up ledges to climb up a mountain. That is pretty good. That is pretty good. And then, I mean, that sort of feels like what it's like being me, that I just like find a hard thing, like a mountain, and just bang my head into it until I succeed. I feel like that's an accurate description of what I do on a daily basis. All right. Let's dig into the shader. Wow, we're 1 hour in, and we've moved on from the renderer plumbing to the let's work on the shader stage. I'm feeling good about that. That's not bad. Okay, so I don't actually think we need to make any changes functionally to the fragment shader, because the fragment shader doesn't do enough interesting things that we need to. I mean, maybe we do. If the fragment shader uses the camera projection at all, then we're going to have to also have it use ours, but it might not. I think this is just a vertex shader situation. Okay, so I'm at the top of the fragment shader, and I'm going to search for projection. So there it is in the uniform. And then we jumped up to the vertex shader. So okay, I don't think we need to modify the fragment shader at all. We just have to modify the vertex shader to use this projection instead of the normal projection when in multi-view, and we have to somehow integrate the eye offsets. And to do that, we're going to look at what Bastian did in the shaders in the Vulkan renderer and try to steal it. Evokes Angry Birds, yeah. Or if you want to see him roll soft body pinball, soft body pinball would be interesting too. Or like soft body pool, that might be a little mobily, but guy trying to code, but his friend Elliot keeps trying to distract him with insane nonsense. All right, so yeah, let's take a peek at the Vulkan mobile renderer, which I have here the PR where Bastian first added multi-view to the Vulkan mobile renderer, but I don't know if this code has changed. So what we need to do is find like this bit of code, but in the current Vulkan renderer. So what file is this? Or no, the forward mobile? Yeah, forward mobile. We want the forward mobile renderer. So we're going to look for scene forward mobile GLSL and try to find this bit, and we're going to take code. We're going to take that code and find how we can integrate a similar thing into the OpenGL renderer. So that was scene forward. Forward. Oh my god. Can I spell? No, I can't. Okay. Ooh! And apparently I was already at that spot. That's fantastic. So somewhere relatively early on, it is grabbing the projection, inverse projection matrices, and then it's using those. So this should be easy. Let's take this code. Let's go back to where we were. Let's find the first place that the projection matrix is used, which is here. And it's doing the exact same thing, basically. We can literally copy that code. That code should work. Yeah. So like all the differences here are papered over between Vulkan and OpenGL. Like this view index is actually called something different in OpenGL and Vulkan, but we have this define up at the top that is getting the right name for it. So again, let's go back down here to the projection matrix, and let's just make sure that that's the only place that we're grabbing the initial projection matrix. Yeah, it is. Okay, so that's one thing down. Now we need to figure out how to integrate the eye offset. So view equals the inverse of the normalized vertex interp, which I guess is a vec3 minus the scene data eye offset view index xyz. What is this code doing? Let's orient ourselves to what is happening right here. So this is the very beginning of the vertex shader. And what exactly is view? Used in a lot of things. A lot of things here. All right, that was not instructive at all. Vertex interp. What is that? Where does it come from? It is the first input, which means it's the vertex. It's the raw vertex, right? Layout location equals 0. In vec3, this is a vertex shader. So that is the input vertex. All right. So we need... Oh, and here it makes it very clear when it sets vertex equals vertex interp. Okay. View. Do we have a variable like view in the OpenGL version? Let's see if we can find the top here. Okay, so here we have vertex equals vertex attrib. So I guess this is probably using vertex attrib as the name of the input. Yep, it's using that to mean the same as vertex interp in Vulkan land. And now we need to see... So down here... Hey, Gabriel Antonio, welcome to the stream! Unless this is spam, in which case... What is this? Oh, it's over. I don't know if you are spam or if you're a real person. If you're a real person, please let me know. Otherwise, I will delete your comment in a little bit. Okay. Times the vertex interp. Wait, how did we get to a vertex interp? Okay, vertex interp equals vertex. I just don't know how to integrate this. Like, are we just moving the whole world the opposite, the inverse direction of the I offset? Hey, Antonio Cano, welcome to the stream. What kind of character did you get? Oh, you got that looks very dwarven to me. That kind of armor and that beard. I mean, it's hard to tell the heights in this world, but I think you're a dwarf. Just saying. Welcome to the stream, and yeah, view. How is view used at the end? Is it used at the end? Let's look at the end where it's actually generating the, not the fragment shader. I need the end of the vertex shader. Okay, this is the beginning of the vertex shader. Can I jump to the other end of this? No, because that took me to the end of the fragment shader. Or am I in the fragment shader? What the heck? Okay, let's start at the top and just make sure we are where we think we are. So let's go vertex, and we need to use the I offset somehow, unless like that's baked into the projection. So I offset, oops, offset takes us down here. This is the first use of it, and then let's search upward for fragment to see if we are in the fragment shader. I think we're in the fragment shader. So fragment shader starts at 382. This is down at 601. Okay, so this is in the fragment shader. So it sounds like the I offset is not used in the vertex shader. It's only used in the fragment shader. And while I'm thinking about it, Gabriel Antonio has not told me that he is a real person, so I'm going to get rid of this message. Okay. So we just need to use this in the fragment shader. So we do need to do something in the fragment shader. That is interesting. So we need to focus our attention not on the vertex shader, but down here. Let's go look. Okay, so here's the main. Oh, and it has a view. It has a view variable, which I'm just going to hope is used in the exact same way. So we can copy and paste this code. It even has vertex interp. Hang on. Let me just put a little thing here so I can find my way back. And then I just want to go look at vertex interp, make sure that it is what I think it is. What? It's in with no layout declaration? Is that okay? Oh, because it has the same name, right. So it's in, it has the same name, so that will get passed from the vertex shader. You guys can see how bad I am at rendering from that stupid thing I was worried about for a second. Okay, so let's go here. We're going to look for I offset. We're going to copy this code. We're going to go back over here, drop this in, get rid of that. Let me just make sure the spacing is similar. Yep, we're just straight putting it in there. And let's try this. Oh my gosh. This is going pretty good, guys. So if this works, which I always prematurely think something's going to work and then it doesn't, but if this works, I think we might have like done it mostly for the desktop, for running OpenGL on the desktop. We have to make it work in WebGL, so to be able to do anything with this. And then we'll have to modify the WebXR module a little bit to get it to render, to use the multi-view data to pass to WebXR. And we'll do it in a dumb, super inefficient way if we get to that point, and then replace it with a nicer, more efficient way later down the line. But getting this to work in WebGL is going to be a little tricky because the way that OpenGL extensions are loaded in desktop OpenGL versus WebGL is like totally different. And I'm not, I have some ideas about how it could be done, but I don't know if Clayjon and the other renderer people will like it. So it's probably worth trying to poke around the code base and see if there's some other code that's doing a similar thing. Or I could just do it the way that I have in mind to get it done, and then after we show it to Clayjon, he can tell me how I should have done it. But yeah, okay. I'm gonna click. I don't know. It didn't crash. It's still rendering. I cannot tell if it's doing the stereoscopic projection right. But we know it's getting the right data. We basically copy and pasted the stuff from Vulkan. So I don't know. I think we might have done it. I think we might have modified the shader. So let's am I in the right branch? Hang on a second. I had a slush branch. Oh man, if we were just doing this all in the wrong branch, I'm going to be upset. So slush 2. Did I already merge the slush 2 branch? Hang on. Slight detour. Slight branch related detour. I thought I was on a slush branch, which is why I committed a new commit. But I'm not. And the question is... Oh, jeez. Did I do something dumb with Git? So, okay, I did diff from OpenGL multiview to the slush. And it's missing, of course, our changes. Which one is newer? Oh, jeez. Okay, well, first of all, since this is the real branch that's like going to the PR on GitHub, I need to rebase it because Godot always wants everything squashed. So yeah, we'll commit this with a commit that's about to disappear. This will be updated shader. And then let's rebase this on master. So pick this one, squash these two. This is really messing up my celebration. I was about to be like so excited, like we did it. And then I just, man, okay. And then we'll force push this. And I'm going to go look at my PR and see if I just totally screwed this up or not. We might have to do some weird merging. That should have been the moment. That should have been our moment of victory. I don't have very many PRs open right now. I think like 4. Ooh, 2. That's even better. Okay, so this, when was my last? Okay, so 3 days ago, I pushed this. What was in those changes? This. Okay. There's definitely more stuff in the slush branch. Whoa. I just wanted to celebrate. Okay, let's go look at the log for the OpenGL slush. Directly draw 2 eyes to the screen. Okay, closer to actually doing a thing. That was from September 20th at 10:30-ish. Let's look in here. 3 days ago, September 20th at 10:30-ish. Okay, there's more stuff in the slush branch than is in the branch that I pushed up here, but I'm going to make the guess, the assumption, that the things I left out were things that I didn't want to be there, and we're just going to trust 3 days ago David. We're going to trust 3 days ago David knew what he was doing when he didn't take everything from the slush branch. I'm just going to take a look at this one more time, and then we're just going to trust 3 days ago me, because I don't recall. I just don't recall. So this is going from slush to us. So this change actually, this looks wrong. That's in the slush branch. We'd be, if we're going to slush, or no, hang on. This is added if I go from slush to... Yeah, okay. We're going to assume that the stuff that's in the slush branch that I didn't bring over was the right thing to do. Okay. And I'll take the moment to say, yay, we did it. And now let's figure out how we're going to get this to work in WebGL. So the thing is, in desktop OpenGL, you don't really have to do anything special in your code, in like the C++ code to load an extension. It's just there or it isn't there. And I guess it depends on how you're actually loading OpenGL, because somewhere, someplace, you need to grab the function pointers from OpenGL for the new functions that get added. But if you're using GLAD, for example, to load OpenGL, it'll just load it. It'll just load it. You don't have to do anything. Just by existing, it will happen. In WebGL, you actually have to like create a new object that has the method on it, and then you have to call that. And I'm not entirely sure what the right way to do that in C++ such that the right thing happens in JavaScript, but I have a thought. So each platform has this GL manager class, which abstracts loading OpenGL, or not loading OpenGL, I guess creating the OpenGL context. Godot is using GLAD, so creating the OpenGL context for that particular platform, and then glad just takes over at that point and actually like loads the function pointers, and you can call the methods and whatever. I'm thinking we add a new method to GL manager, to the parent, that somehow, oh, there is no parent. How does these get called on all the different platforms? That's interesting. Well, that's a new question, a new thing we have to figure out. So in this somewhere, wherever this comes from, we're going to need to say like, hey, load this extension for me, or maybe even just like execute this one extra function that the extension has for me, and then we will provide like a default implementation which uses, you know, the just uses glad. It's like, hey, I already have the function, we're good. And then in the JavaScript platform, we'll do the stuff that JavaScript has to do. So I guess first of all, we need to figure out like how this is getting called. Like, okay, we're gonna search for GL Manager X11. GL Manager, I did not mean to make caps lock happen. Nope, still I don't want caps lock. Manager X11. And we don't want to search here, we want to search everywhere. What does this one do? Match whole word, interesting. Sure, match whole word. So where does this get called? In the display server? So display server. Oh, interesting. Okay, so in the X11 display server, it says if GLES is enabled, it has this GL manager. If Vulkan is enabled, it does this. I imagine the DirectX one will add another thing here. So then what we really need to do is have display server give us a method. Let's go look at the declaration for the display server parent class. But this is weird though, because like we don't want it necessarily to be on the display server, because like we don't want anything outside of the renderer to call this, right? Like, I don't know. See what other methods there are on here. I wonder how does Vulkan deal with this problem? I mean, I guess it doesn't. It doesn't deal with this problem because it can do everything comfortably in C++. We have the problem that we need to like have a special branch that happens in JavaScript when you are in the web platform. This is getting like kind of low level here. Swap buffers, make rendering thread, release rendering thread. Like this is the low levelness of what we want to happen. Hey, hang on a second. Register create function, get create function, get create function name. What is all of this? Rendering drivers function. This could be interesting. Rendering drivers function. It's a vector of strings. Okay, so there's a set of strings. How do we go back to where we just were? We're still in the display server, but we're way at the bottom. Okay. Get create function rendering drivers, get create function name, create. This sort of seems like it's abstracting some stuff from the rendering driver, which we want. But this seems like it's something different. Like maybe this is how it gets initialized. Let's see if we can find the implementation here. So create render, register create function, server create count, get create function rendering drivers. I think I'm going in the wrong direction here. I think I'm getting lost in something that isn't actually going to help us. Let's go about this a different way. Let's go look at the web platform, which I keep accidentally calling the JavaScript platform because it was called the JavaScript platform until very, very recently. It's still called that in Godot 3, and it still is in my fork. How old is my fork? Pretty old, I guess. All right, well, let's look. I think we're gonna have to update and rebase before we try to hack on this. Unless this is just leftover stuff. This is just leftover junk. Okay, this is like build artifacts. So we can delete this. We can delete this. Okay, got rid of the JavaScript platform. Now we have the web platform. And let's look at how it does OpenGL and see if it leaves any space open for us to do what we need to do, which is load the multi-view extension. Godot WebGL 2 header? That's interesting. Yeah, maybe let's search in here. Find in folder. We're gonna look for, I don't know, things with GL in the name. There's some JavaScript stuff. Let's look for things with context in the name. So audio context, audio driver, display server, GL ES3 enabled, mscript and GL context handle. So it gets us the context handle. This is display server web. So this is the web version of the display server. Antonio Cano says, damn, it is really hard to create custom resources and try to make it somewhat good looking on Godot. So custom resources meaning like you're making like a .tres to hold like weapon data or something like that for your game. So I saw someone made a plugin that will turn all of the custom like .treses in a folder into a giant spreadsheet, which sounds terrible but also sounds amazing. Because I do a lot of that stuff where I make like custom resources to be like in Retro Tank Party, all of the power-ups are custom resources, which are conveniently all stored in the same folder, which would work real good with this spreadsheet thing. I haven't had a chance to try it though yet. Get rendering drivers func. Okay, yeah, so I think the thing we were looking at before does do what I started to suspect it does, which is just creates a function to initialize the rendering driver. But, okay, here we go. Here's some GLES stuff. WebGL, mscriptin GL context attributes. I wonder if mscriptin provides something nice for this. Let's search for that. Mscriptin WebGL 2 extensions. All right, that was not good results. We're going to leave the Brave search engine and type the exact same thing into Google. WebGL, mscriptin, okay, hang on, we'll say mscriptin, WebGL extensions. If what is the defined for when we're in JavaScript, when we're in the web platform? I don't know. We'll have to go look at the web platform, which I guess we'll say like web OS something. That'll get us to the right neighborhood. And let's look at the SC sub. And this should help clue me in. Oh, okay, new plan. I have to use it in WebXR. I have to use it here. Web enabled. Okay, if we are web enabled. So let's go back here and let's say if web enabled, we do something else we do this, and if, and then here we go, we'll say not defined GLES over GL. Over here we'll say web enabled. And then what we want to do here is include GL / GLXH. Does that sound rightish? Right? I don't know if any of this is going to work, but let's do that. And I don't know if we even need this type def, honestly. But we'll leave it there. I may just have to have like a conversation with ClayJohn to figure out like how all of this is supposed to work, because I don't know. But then we get down here, we say if not defined GLES over GL and not defined, what was it again? It was web enabled? Web enabled. Web enabled. And we need to take this code to the other place that we're doing this exact same thing, which we'll see in my MR or PR. How am I so lost? Okay. Files changed. I guess we'll search for this GLES over GL, because we do this in a couple of places. This render scene buffers GLES and texture storage. Yeah, for creating the render targets. Okay, texture storage. So let's go back here. We will start by copy pasting this junk that is probably wrong, and take that over to texture storage, GLES 3. We'll place this other stuff that was at the top of here originally. And then we are going to go to where we're using this function pointer and add the and not defined web enabled. I have no idea if this is right, and we're gonna have to start building the web platform to find out if it is right. And because we just built for desktop, building for the web platform is going to take extra long. But let's press the build button, and it might crash early enough that we can work on this. Otherwise, like it's the end of stream time, guys. Let me see what's going on in chat. YouTube stream is back. The YouTube stream is back for the last moment here. I wonder if like we rewind in the stream later, if it'll have all of the missing stuff, or if that's just lost forever. You know, it'd be kind of cool if it like captured it still, but just didn't get it out there. I'm reloading the YouTube Studio stuff on my end to see what's going on in here. Yeah, it's back up. It's back up. It says 2 people. 2 people are watching on YouTube. Interesting. We'll have to read all of the articles that come out over the next day or two explaining the YouTube stream outage. Well, thanks everyone for coming to hang out. Sorry about the YouTube problems. I don't know what the deal is with that. Okay. Well, it did crash right away. Hang on. We're not saying goodbye just yet. Let's let's do one more quick thing. System include GL. What is the gl.h? Here's what we're going to do. We are going to go to... We're going to make one more tiny change before we leave. We're going to change this to just GL. And we're going to copy that over to this one as well. And we're going to hit compile. And we're going to watch the compilation as we say our goodbyes. All right. All right. Thanks again, everyone, for coming to the stream. Despite the technical difficulties, it was a super fun stream. We accomplished a lot. Like, I am just amazed that we managed to get this to work as well as it did. And yeah, thanks everyone for coming. I hope you have a great weekend, and I'll talk to you on Discord. See you next week. Everyone, take care. Bye-bye.